Hello all. Here in this video we are going to see the most important topic, first topic of our basic data structure called linear search. That means I want to search one element among my array elements. I need to know where that element existed. So I want to search one element means first there are several other techniques are there, but here first technique we are going to use that as the technique name called linear search. That means I am going to compare each and every element with my particular key element. When it is found, it will going to return the index value of my element. Okay, for example, here I am saving my whole bunch of particular arrays. Either you can using scanf also you can do, you can alter this program. So in the index number 0, 12, index number 1, 34, index number 2, 55, index number 3, 6, index number 4, 87, 91, 45 and 32 I am saving. Okay, so from the 0 to n minus 1, my array memory is allocated in the integer, my variable in the ARR. Obviously, here I am introducing somewhat the new term. I have to find the size of my particular array. How do I find? So, one simple logic. What is the size of my particular array? And what is the size of any one sample element? For example, here how it will be means size of an array, actually integer it is. So how many elements are there? 1 2 3 4 5 6 7 8. So 8 fours are 32. So totally each integer will have to allocate the 4 bytes. So totally 32 bytes it will allocate. Divided by what is the size of my particular one integer value in my array? 4. So 84 divided by 32 divided by 4 is equal to 8. You see that I am having 8 data in my array. This is how this particular line works. Simply we can find based upon my particular my array value, I can find my n. This is another technique. No need to get the n value from the user. We can use this formula also. Obviously, I am going to start the for loop from 0 to n minus 1. Okay. So now what I am doing is I am going to check a of 0 is double equal to key. Okay. So from what is a of 0 is storing 12. Okay. So 12 is double equal to 87. Okay, because key value is what? 87. 12 is equal to double equal to 87? No. So the condition false. It will come out. And then it will going to just print me element not found. Obviously, but I am not searching 87, no. So my for loop continues. Then it will go now my I value increases as 1. So array of 1 is double equal to key. Array of 1 will be 34. Double equal to key means 87. Condition false. Again I will be incremented. 55. That means array of I value 2. In the index number 2, 55 will be there. 55 is equal to 87. Condition false. 6 is equal to 87, condition false. Obviously 87 is equal to 87. Yes, it is found. So 0, 1, 2, 3, fourth index. It will existed in the fourth index, fifth element, as well as it is existed as a fourth index. I am going to print the index value. If you want to print the position, you need to give I plus 1. But if you want to print only index, it is enough to give I. So I am going to get print my value, but when my operation found, I am going to just assign as found is equal to 1. That means I am assigning found as a true value. I am breaking out of my for loop. I don't want to search it in anymore because I already found my data. So I am break my execution loop. I am coming out of my loop. Okay, then I am my program ended. For example, I am executing it. Okay, those are some basic errors. So you see that element is found at the index number 4. This is how my linear search works in the for loop. But there is another method to implement there. Okay, that is using recursions. How the recursions works? Okay, so recursion here, how it is working means, as we already know, what is recursion? The function that call itself. So what I am going to do means, now I am going to just initiate the linear search recursive function, but now I am going to pass my array as a parameter. We can pass array as a parameter and the key value and the starting value and the ending value. Okay, now imagine that here I am giving the same array value here. I am going to give the same array value. So my array as well as here, let me remind that thing, the size of my whole array will be 32 divided by size of each data in my array is 4. So totally I am having 8 elements here. My key value is 87. Now instead of the for loop, I am going to give I am just going to pass my array is this ARR and the key value, and 0 is my first index and n minus 1 is my last index as a parameter to the recursive functions, to the linear search recursive. Now it will pass the parameter, the whole array will going to pass as a parameter here. Now what will happen is array key value 0 n minus 1 will pass here. Array key value is 87, n minus start value is 0, n value will be n minus 1. That means 0 to 7. So what is the value? So let's see the parameter array value 8 array values it will say, and followed by key will be 87 and 0 and comma my n value will be 7, it will be passed here. Okay, now I am going to check whether is start is greater than 7 or not. That means 0 is greater than 7. So obviously condition false. But why we are checking it means, for example, I am going to check all the index in my array. For example, when in my recursion state it is getting as 8 means already I am having only 8 data. So but I am just giving my 8th index, there is no other data. So obviously there is no element in my particular array. So it will return as -1, no issues. Okay, so I am giving as start is greater than the end, that means 0 is greater than 7. So obviously condition false, then it will come here array of start, array of 0 is double equal to 87, it will check. So obviously condition false, and then it will not going to print. Then because array of 0 I am having as 12, then it will going to return me the result array value again, key value again, but I am here I am entering start is equal to 0, start plus 1. So start plus 1 means already start value we are assigning as 0. So 0 plus 1 1 and n value same 7 it will be. Now I am going to check start value 1, so 1 is greater than 7. Okay, now I am returning my whole function. No, again it will call it the whole function like a recursive process. Again it will I am going to call 1, and then here the condition false. 1 is greater than 7, condition false. Now I am going to implement my start value in my array. ARR of 1. Okay, in the ARR of 1, what is the index? What is the value? 34. 34 is not equal to 87. So it will going to come out. You see that here linear recursive function again I am going to call. Likewise again and again and again it will going to start, and then in especially when the start is becoming 4, my particular linear search will start executing the it's giving me the result. This is how my particular recursive, using the recursion, I am executed the particular linear search. Thank you.